All right, hey everybody, this is Brandon here. I actually wanted to spend a couple of minutes this morning walking through the new Particle Workbench extension for Visual Studio Code. If you haven't had a chance to use this yet, really exciting new tool, makes it a whole lot easier to do IoT development with particle devices, both second generation devices like the photon and the electron, and also as well as our new third generation devices, the argon, the boron, and the xenon. So let's go ahead and check it out. First thing I'm actually going to do is change my theme to light mode so that maybe a little bit easier for y'all to see. Prefer dark mode, that's all right, this will work. All right. So installing the extension means it's actually still in a preview, and you can get the preview by actually heading over to particle.io and /workbench and sign up for the preview there. You can check that out. And you'll very soon after you fill out the form for the preview, you'll actually get a download link with a VSIX or VSIX file. You'll download that VSIX and you'll actually come into your browser, into Visual Studio Code, and click on the little gear in the lower right-hand screen, click on Extensions, and at the top you can actually click on Install from VSIX, the little three ellipsis menu here, click on Install from VSIX, and that'll open up. I got mine in my downloads folder. I pulled it in. That'll install the extension, and it'll actually give you a little notice when the installation is done. You'll get a toast in the lower right-hand corner of the screen here. You'll see load, reload your browser, reload VSCode in order to see it. You'll actually see a Workbench screen come up pretty soon after that. See if that's coming in. Oh, there we go. Welcome to Particle Workbench. And this actually shows you all the different things that you can do with the Workbench, a bunch of different commands. You can click on these things. The first one is actually opening the command palette. So this is an important thing to get used to. If you're on a Mac, you want to type Command-Shift-P. That opens the command palette if you're not used to that already. Or Control-Shift-P if you're on Windows. But Command-Shift-P is going to be your best friend when it comes to Visual Studio Code, and definitely for the Workbench extension as well. So there's a number of things that you can do. We'll go through each one of these, installing local compilers, launching the CLI, different things like that. But the first thing that we want to do is create a project. So I'm going to do that by actually opening up a folder. So I'm going to click File, Open. I'm going to open just my development folder on my computer. When I open up my development folder, that'll give me the place where I'm going to create new applications from there. So I have a particle folder here as well, but I'll just put this at the root of the development folder, and I'll click Command-Shift-P, and then I'm going to click on Particle Create New Project, and that will, as soon as that extension is loaded, that'll actually ask me for the name of the project and location. 1 second. Create new project. There we go. I'm going to open the folder here. Okay. 1 second here. I got it too early. So I open my development folder. That's where I am. That's going to reload. Open up some other things here. All right. And it's asking me now for the project name. Project name that I'm going to give is, let's see, I will just call it, oh, I'm getting some .NET stuff, dependencies that are installing automatically. So bear with me for a second here. Do Command-Shift, oh man. Ill timing. Okay. Command-Shift-P, create new project. I have a folder open. All right, do it again. Look at those .NET CLI tools. Okay, project name is going to be Particle Test. I'm going to create it right there, and that's going to open it. What that's going to do is it's going to create a new folder for me. It's going to put in a code workspace folder for me. The way that the VSCode, the Workbench extension works is it uses the code workspace file to manage things like target devices and things like that as well. And that's actually one of the first things that you'll want to do when you create your first project. And you'll see in your code workspace, there's different things in here, settings. But one of the things that you'll do if you click Command Shift P is configure workspace for device. And what I'm going to do, when I do that, that actually pops up a window here, and I'm seeing it's actually, oh yeah, it is showing up in the stream now. That actually shows me various versions of the device OS firmware. So I can target different device OS firmware. I can target different devices as well. So in this case, the first thing that I'm going to do, because I have a photon here, I'm going to actually put device OS 800 RC10. I'm going to target the photon, and the name of this device is library tester. And I'll hit enter. What that'll do in my code workspace file is it actually adds that as my target device, so I don't have to re-enter that every single time. You'll notice also while all this has been happening in the lower right-hand corner of the screen is that I'm actually also seeing some information about my compiler toolchain being installed. So one of the things that the VS Code extension makes a whole lot easier is installing the right dependencies in the compiler toolchain to do local compilation. If you've been working with Particle for a while, you know that you could set this up on your own. But a lot of what we would propose as sort of the preferred way to build was to use either with the web IDE or even with the old Particle Dev IDE, cloud-based builds were sort of the preferred approach. And while that's still the easiest way to build against your Particle devices, it's not the only way. And what we provide in the VS Code extension is actually a nice self-contained segmented way of installing the right toolchain without interfering with other build toolchains you might have on your machine. And so we handle the right toolchain per device OS version, for different kinds of hardware that you want to target as well. And so one of the ways that you can interface with that inside of the Particle windows, inside of the command palette is to go to Particle install local compiler. And so as I just picked for the device I was targeting, the same thing happens here when I choose a local compiler. So if I want to install an older version of the device OS against the Photon and the Electron, or one of the newer versions of our device OS that's targeting the 3rd gen hardware, the Argon, the Boron, and the Xenon, I can choose that here, click on it. That will actually download the toolchain behind the scenes, install it, and get everything ready to go. Let's actually get into writing code here. So I had a file, a test sketch or file that was created here for me when I created the new application. I'm actually going to pull in the Tinker firmware, and you'll see that here. The Tinker firmware, if you are not familiar, if you're using a brand new Particle device, this is what comes pre-installed as the user firmware and devices that come from the factory. This allows you to do things like set certain pins low and high from the mobile device or from the console, etc. So I can do that. Here. So you can take that Tinker firmware, we have it available, and you can install it on your own devices whenever you want to as well. So I'm going to install this to this Photon. This is the device here that I got my hand on the screen. And I'm going to open up the command palette, and I'm actually going to pick Particle Cloud Flash. So I'm not going to do a local flash right here for the purposes of this demo. We can do that in another stream. But I'm going to do a Cloud Flash. And let me make sure that I'm actually targeting the right device here for a second. So that's an important thing to figure out. Opening up a different window here off screen in the console to see what's happening. Oh yes, this device's name is Bacon Mutant. I called it something different. So I'm going to go back in, Command Palette, Configure Workspace for Device. I'm going to go into Photon, and then the name is going to Bacon Mutant. Hit Enter. So now when I take Cloud Flash, or go back to the Command Palette and do Cloud Flash, you'll see in the lower right-hand corner of the screen, it's preparing, it's doing a cloud compilation. It's going to flash the device. You will see this device turn magenta here in a moment. There we go. As the flash is actually happening over the air. This actually is connected to power, but it's not connected to a serial port. It's just powering the device right now. So that's flashing that. That's turning it online. And what that will give me the ability to do is write commands against the device. Excellent. And so I'm going to show another feature here. I'm doing this one on the slide. I didn't decide to do this until just now, so we'll see how it goes. You can also launch the Particle CLI from within inside Visual Studio Code. So I can open up Particle CLI and I can run commands like Particle Who Am I? This tells me how I'm logged in. I'm logged in as Brandon at particle.io, and I can do Particle Help. And see what's going on. So I can do things like calling variables, webhooks, things like that as well. calling functions, which is what I'm going to look at right now. So if I do particle help, or excuse me, if I look at Tinker, there's actually a digital write function that I can call against any pin on the device. So I can call particle, function, digital write. Remember the exact syntax of this, Oh yes, particle function call. There we go. Particle function call, bacon mutant, digital write, lowercase, and I'm going to do the argument I'm going to pass in is setting the D7 pin high. And when I hit enter, if it works, you'll see the D7 light on my photon actually turn on. Now if I call the same CLI command, set my D7 pin back to low, hit enter, that light will turn off. So all of this I did from inside of the VS Code extension inside of Particle Workbench, which is really exciting. I didn't have to bounce around in a bunch of different places. We also have the ability to target multiple devices. So I have a Xenon that's here as well. So I can actually change my target for the Xenon or to the Xenon. And so I'll actually do, again, configure workspace for device. I will target RC27 of firmware version 080. I'll choose the Xenon as my target platform. And this one's name is library tester 2. Hit enter. And that's going to configure that for me. And from here, I'll actually show you very quickly doing a local. I'm going to reload this window to finish everything updating. It actually made sure the compiler toolchain was there and ready to go. So here I'll actually do a local compilation. So I have the local compiler installed. I have everything that I need, and I will do a local build. And in order to do a local build, you'll actually run a build task. Oh, came back up real quick. Okay. Hold on, cancel. Run a build task, and I'm going to choose compile or flash application. So in order to do that local, I do have this device plugged in. I'm actually going to need to go into DFU mode. So in order to do that, I'll hold down both buttons to go into device firmware update. I'll let go of the reset button and hold down the mode button until this light starts flashing yellow. So you'll see that here. That means that the Xenon is in DFU mode and it's ready to go. So I'll click compile application or flash application local. You'll see that's what's happening in the tool. It's actually going against my local tool chain. So sorry, excuse me. Running the build against that locally, and then it's actually did the DFU update. When you see this wonderful little progress bar right here, command line based progress bar, you're seeing that information right there. So now I should have Tinker on this device as well. So I can go back to opening the particle CLI. Excuse me. And in this case, I'm going to run a similar command, but in this case, I'm going to call that same function on my device, library tester 2. So setting D7 high, if this works, there you go. You see the D7 pin on the Xenon was actually set high as well. Now set it back to low. Device is turned off. So again, I was able to target two drastically different kinds of devices, different microcontrollers with different targets, different build tool chains, etc., and very quickly get those across those two right there. So now that's interesting and all. There's some other things that you can actually do inside of Particle Workbench as well. And so I'm actually going to install a library now. So this is an important piece of the tool chain for most of us, or the experience for most of us, is bringing in code from other libraries and other places as well. And so I have a Adafruit Featherwing and OLED Featherwing on here that I'm going to install a library for. And then I'm going to change my code in here to actually call against that. So copy in some new code here. What this code is doing is just running an OLED wing library that we've provided. And it does a couple of different things. In the loop, it actually looks to see which button has been pressed on the wing. And if you press A, it shows hello world. If you press B, it does a graphics test. If you press C, it does a bitmap test. So all those nice fancy things for you to see. But in order to get this to work locally, I need to install a library. So I can click Command-Shift-P, particle install library, and then ask for the name of the library. So the name of that library is OLED Wing Adafruit. Then hit enter. In the lower right hand corner is my status window. It's installing that. And what this is going to do here is it's actually going to add a lib folder if you don't have one already. It's going to install the library. So you can see the sources here and all of the various dependencies. This library actually depends on a few other libraries, an SSD library, the Adafruit GFX library, and the debounce library as well to handle those button presses. So once I've got those installed, this actually should work for me. So I can run a couple of different commands here. I can go back to doing my local compilation, but I can actually also go in the build task and just do a local compile as opposed to doing a local flash, just to see and verify that everything works. When I run a local compile, this not only gives me, all right, so it's running that local compile right now, throwing a couple of warnings up there. Really what you want to see there towards the end is that the compilation is finished, and you'll actually get binaries in a target directory that gets added in your local project as well. So I actually have that binary here, or it's in the process of building it right now, but when it's done, I can actually either use the CLI to manually flash that over myself, or I can go back and use Workbench to flash that for me. So you notice it's done now. It'll give you something, a message a little bit like this to show you that it actually did the compilation where everything went. But now I can go back in the command palette, run the build task, and I'll do another flash. I'm gonna go back into DFU mode. And I will very quickly flash the device. It's already built, so it'll use the sources that it's got. Do that DFU flash, and I am good to go. When this loads back up now, I should be able to interact with the device and see some things happen. Nope. Something being written to the screen. I think I may have an issue with this screen itself, so let me pull in another one and see if that actually works. Because I know this code does. Restart there. All right, here we go. So I've got a hello world there. See that? I can hit the second button and get a nice little graphics test on there as well. Or hit the third button to do a little star animation. So that's just a few of the basic things that you can do inside of the Particle Workbench extension. A few others, if you actually look at the launch page, you can get an idea of some of the other things that you can do. There are a few different particle themes that you can install. So I changed my theme earlier from dark to light. There actually is a light particle theme that uses some of our wonderful cyan colors. There is a dark particle theme as well. So as you can actually see these as you're going through those commands. Go back to the light theme. You can mess with project settings here. Again, as I mentioned, install particle libraries. One thing I didn't show yet is you actually also get snippets and IntelliSense. So those are worth showing off very briefly as well. So there's a number of snippets that we provided that do some basic things or some very common things that you'll do in the context of particle. A lot of these are really easy to trigger. So if you're doing a particle publish and I type PP, you'll actually see a lot of these here. We have a particle process. We have a snippet for publishing as well. Excuse me. So I can type in particle publish an event name, call it foo, pass in a payload of hi. I can do particle subscribes as well. I can create my particle subscribe. Let's see, where is this going to be? Might be down a little bit. Particle subscribe and give that a name of bar and pass it off to a handler. And I'm just going to call this my handler. So, and then outside of my setup or elsewhere in the sketch, I can actually do particle subscribe handler or PSH. And that I can pass here. So I'll call this one my handler and write my code here. So console. I need snippets because I cannot type. All right. So there's a ton of different snippets as well. You can actually see those in our GitHub repo. We have a snippets extension that is that's part of that repo as well that has information about all the different snippets that we have. But a lot of the basic things that you would use Digital write is in there as well. Oh, let's say I need to exit out of this. Escape. Digital write. We have pin mode is, I believe, in there as well. So pin mode initialization, a lot of the basic things that you would expect to do. But then a lot of the particle commands are in there as well. I mentioned particle publish and subscribe. Particle function is in here. Particle variable as PV. Getting your product ID version. This actually sets up those user snippets at the very top of your source code as well. So there's some interesting stuff there. And then we also have support. You can actually dig into individual libraries. This is one of the great powerful things about Visual Studio Code, is that I can actually go to definitions or peak definitions of different, of the source that I'm using inside of libraries as well. So I can actually get to see what's happening, to actually go to my definitions or declarations, dig into the sources. I'm working with libraries as well. Makes it very transparent what's actually going on under the covers. So quick overview. If you have not yet checked out the Particle Workbench extension, definitely check that out at particle.io/workbench. Sign up to try it out. We're actively making changes on it, so give us feedback on Twitter or really any place you can find us in the community as well. So thanks for taking a few minutes to watch it, and have a great weekend.